SQA Advanced Higher Maths 2018, question number 12. Prove by induction that for all positive integers n, the sum of r equals 1 to n of 3 to the r minus 1 is equal to 1 over 2 times 3 to the n minus 1. This is for 5 marks. Consider n equals 1. Left hand side is equal to 3 to the 1 minus 1, which is equal to 3 to the 0, which is 1. Right hand side is equal to half times 3 to the 1 minus 1, which is half times 2, which is also equal to 1. So that means that left hand side is equal to right hand side, which implies that it is true for n equals 1. Assume true for n equals k. So that means that the sum of r equals 1 to k of 3 to the r minus 1 is equal to half times 3 to the k minus 1. This is your inductive hypothesis. Let's call it 1. Consider n equals k plus 1. That implies that the sum from r equals 1 to k plus 1 of 3 to the r minus 1 is equal to the sum of r equals 1 to k of 3 to the r minus 1 plus the next value, which would be 3 to the k plus 1 minus 1. So that would be equal to, now you bring in your inductive hypothesis here. So that means that what you have is half times 3 to the k minus 1 plus 3 to the k plus 1 minus 1 is just 3 to the k, which is equal to half times 3 to the k minus a half plus 3 to the k. That gives you 3 to the k as a common factor. So what you have is 1 plus a half, which is 3 over 2 minus a half. What you have is 3 over 2 times 3 to the k minus half. You can take a half outside. So what you have inside is 3 times 3 to the k minus 1, which is half outside 3. This is k, 3 to the 1. So adding the indices gives you 3 to the k plus 1 minus 1, which is the required result. So that means that it's true for n equals k, and you proved that it is true for n equals k plus 1, since true for n equals 1, that implies it's true for all n member of natural numbers, positive integers. That is for 5 marks.